Hello guys, welcome back to my YouTube channel. So today we are going to solve problem number 3532, path existence queries in a graph 1. Okay, so this question is also asked in weekly contest 447. So without any delay, let's get started with this problem. You are given an integer n representing the number of nodes in a graph labeled from 0 to n minus 1. N is equal to 2, that simply means we have nodes 0 and 1. Alright. You are also given an integer array nums of length n sorted in non-decreasing order, increasing order, and an integer max difference. Okay, so the values are sorted in increasing order and max difference value given to us. An undirected edge exists between nodes I and j if the absolute difference between nums of I and nums of j is at most max difference. Okay, so nums of I minus nums of j, if I do, okay, so absolute difference between them, it should be less than equal to the max difference value, right? So 3 minus 1 value is 2, and 2 here it is less than equal to this max difference. Tell me no, right? So definitely there is no edge. So 0 to 0 here uv value given to us, so 0 to 0 we can go, so here I am returning true. 0 to 1 we can go no, so I am returning false. Okay, I will cover this here. So you are also given a 2D integer array queries. For each queries of I uv, determine whether there exists a path between nodes u and v. Okay, so this is the uv value given to us. We have to return a boolean array answer where answer of I is true if there exists a path between u of I and v of I in the ith query, and false otherwise. So example 1 I think is already clear. Okay, from here node 0 has a trivial path to itself. 0 to 1 there is no edge between 0 and 1 because nums of 0 minus nums of 1, 1 minus 3 is 2, which is greater than max difference. Thus the final answer after processing all the queries is true false. That's it. Okay, now see this example number 2. All right, and before that let's see the constant size very large, 10 to 5. Okay, so we can't implement bfs here actually in this problem. Why? Because here if you see this query's length is also 10 to 5. All right, so if first for this, if I implement bfs for this, if I implement the bfs for this query, if I implement the bfs, okay, there are 10 to 5 queries. Okay, and nodes is also value, and value is also 10 to 5. Okay, so 10 to 5, and for all the queries if I process, I will get time limit exceed error. Okay, so let's not think about bfs right now. Okay, so here I will show you one more important thing, that how we are going to solve this problem. Okay, so it's definitely not bfs because of time limit exceed. All right, so here n is equal to 4 and 2 5 6 8. Okay, so here graph is there, right? So let's use this. So here we have node 0 1 2 and 3. Okay, so here max difference 2, so here there is connection between them. 5 minus 2 values 3. 3 is less than equal to my max difference, no, so there is no connection, right? And these values are already increasing order, right? There is no connection with 0, right? Okay, 5 6 there is a connection, right? Value is 1, it's less than equal to 2, yes. So here 1 and 2 there is one connection, right? Same way 6 to 8 there is one connection between 2 and 3, right? So that's it. So connection is there, right? So first we are just going to prepare this graph, right? So here this is done. Now here 0 to 1 you can't go, right? False. 0 to you can't go, return false. 1 to 3 you can go in this path, true, return true. 2 to 3 you can go, return true. Okay, that's it. But how we are going to solve this? Okay, so problem statement is very easy, right? So now how we are going to solve this, let's see that. So first what I'm going to do here, we know that we have nodes 0 1 2 3. Okay, so for all these nodes I'm going to use this find union data structure. Okay, so disjoint set union, right? So I can use that. All right, so here we have nodes 0 1 2 and 3, so I will say that 0's parent is 0 itself. Okay, 0 is one separate component, 1 is one separate component. I am not creating any links right now, so 1's parent is 1 only, right? 2 parent is 2 only, 3 parent is 3 only. This is the first thing that I have to do, right? Now after that, here I will just iterate over this 2 5 6 8. Okay, 2 5 6 and 8. So from here max difference is 2 given to us, right? So you know that from here to from here difference is greater than this 2. Okay, so definitely there is no link between 0 and 1. Okay, so let's suppose I am here. Okay, my I value here. Okay, right now I is at 1. So at I is equal to 1, I will just compare this and I minus 1 difference. Okay, and I will check whether it is less than equal to this value. So no, so there is no link. So what I will do, I will not change the parent of this one. Okay, it will remain 1 only. Now here 5 and 6 there is a connection, right? So 6 minus 5 difference is 1, 1 is less than equal to 2, there is a connection. Okay, so here right now my I is here at this point, right? So there is connection between this 6 and 5, right? So here that simply means that 1 and 2 there is one connection, right? So that simply means they are linked. So what I'm going to do from here, I will update the parent of this. So I will update the parent of this using this one. So what is the parent of this? This parent is 1, so I'm going to use 1 here. Okay, previous one, because there is a link, so I'm going to use the parent of previous one. Okay, so here I'm writing 1. This is done. All right, so now after that your eye is going to move to the next position. Okay, so right now your eye is here. All right, so now I'm going to check 8 and 6. So is there any connection between 8 and 6? Okay, so you are going to say that yes, 2 value 2 is less than equal to 2. Okay, so 2 is nothing but difference and this max difference value. So yes, there is connection. So definitely there is connection between these two, right? This and this, there is connection, right? My I compared this and this now, so definitely there is connection. So what I will say, tell me the parent of this. Okay, so here you go to this okay, so and you will find out that the parent is 1, so you are just going to operate it 1 only. That's it. Okay, and in the end what you need to do now, it's very simple. Once you are ready with this, so you have to iterate over all this. So 0 and 1, 0 and 1 both are having different parent, return false. 0 2 both are having different parent. Okay, here we are writing the parents inside, right? So return false. Okay, here 1 and 3, so 1 is having 1 and 3 is also having 1, both have same parent, return true. That's it. Okay, 2 and 3 same parent, return true. Okay, 2 and 3 same parent, 1 1 and return true. That's it. Okay, so let's write the code. It's very simple actually, right? All right, so here what you need to do, first of all just create one parent array. Okay, so here private int, and here you have to write parent. Okay, and now here inside this just initialize this parent is equal to new int, and here give it the size n. Right, and then make every node as itself their own parent, right? So here you have to write int I is equal to 0, I is less than n, and here I plus plus, since we have nodes from 0 to n minus 1 now, right? So here parent of I, I'm going to say I only, right? This is done. Then after that we have to check one more thing, we have to iterate over the all this nums array, right? So here nums array is having same size. Okay, and n value is the size of nums array. Okay, int I is equal to 0, I is n less than n. Okay, and here I plus plus, this is given in the problem statement itself, right? Okay, you are also given an array nums of length n only. Okay, so right, so don't get confused here. So here we will just check this now, if nums of, and here I have to start from 1. Okay, because I have to check the previous value, right? So nums of I minus nums of I minus 1, since array is already sorted, so we don't need to use math.absolute also here. Okay, because nums of I value will always be greater than nums of I minus 1. Okay, is less than equal to this max difference. All right. Okay, now here, okay, here, yeah, this is given now, is sorted in non-decreasing order. Okay, non-decreasing order, so it will be increasing order only, right? So that's why I'm not using absolute. So here you have to update the parent of current I. Okay, if this condition is satisfied, right? So here, right here, if you see the condition was satisfied where we were writing to, but there was a link here. Okay, so we have to update this parent using the this values parent. Okay, so here parent of I I'm going to update, and here I'm just check the parent of the previous one. So find parent of I minus 1. Okay, so here I will write one more method here, just by going to very small code. Okay, so here just write this. So how we are going to get the parent of the previous one. So here very simple now, public, we have used this code so many times, int find parent. Okay, int I. So I values I am passing something, right? So now here, if the previous value that I am passing, if the parent of that particular value, okay, if matches with this itself, okay, parent of I is equal to I itself, then simply return I. Okay, right? So here if you see, here it was 1, here it was 2, okay, initially. So here I go now. So here this one and this one both are matching, so I am simply going to return 1 here. Okay, return I value here. Okay, this is done. But here it was 1, here it was 3 initially. Okay, so how I update 1 here then? Okay, initially it was 3 now, in the starting it was 3 only. So then how did I update? So if this is not the case, because here if I move to backward, okay, here if I check here, so here this is 2 and this is 1. So what I'm going to do next time, I am again going to find the parent of this one. Okay, again I reach here. So now here 1 and 1 both are matching, so I will return this one value here. Okay, so we have used this code so many times, right? Nothing complex here. Return parent of I is equal to, again I'm going to call this find parent. Okay, find parent, and inside this I'm just going to pass parent of I value. That's it. Okay, this is done. Now in the end, just you have to return the boolean array now. Very simple code, only 2-3 times pending. Now boolean answer is equal to new boolean, and here queries dot length. Okay, and here just iterate over all the queries one by one. Int I is equal to 0, I is less than queries dot length, and here I plus plus. Okay, inside this answer of I, okay, you are just going to update it, just compare the parent of both, right? So find parent of here queries of I and 0. Okay, it should be matching with queries of I and 0, it should be matching with here. Just find parent of queries of I and 1 here. That's it. Okay, if it is matching, right, so it is going to return true, otherwise false, and here you have to just simply return answer in the end. Now let's run it and see if the encode issue will try to fix that. So yes, there are some issues, let's fix that. So see, all the test cases has been accepted, right? Now let's submit it. So see, our solution is accepted, right? Now this is very easy code, right? So here we can update few more things, okay, to make it more easy, right? Let me show you approach 2. Okay, so this is my approach 1 of solving this problem, and this is also very easy. There is one more approach in which we don't need to use this find parent. Okay, so I will just find out the components, right? So here like we have this 2568, right? 2568 we have, right? 2568. All right, 2 5 6 and 8. Okay, and we have max difference value is 2, right? So take one component id, and here in this component id assign 0. Okay, then again start from here. So just compare the difference among them. So now right now here initially component id value is 0, right? And you have to take one component array also of the same size. Okay, and inside this just pass 0 0 everywhere. Okay, now initially. Okay, right? Now here when your I is here, so you will see that there is a difference greater than 2. Okay, difference 5 minus 2 3 is greater than 2. So in this case what you are going to do, you are going to put this in some other component. So you are going to increment the count and place it to 1, right? So now next time your I is going to move here, see no difference, so definitely 5 and 6 will be remain in same component, so you are going to not going to change it, it will remain 1. Next time here your I is going to move here, there is no difference, so both are going to remain same component, you are not going to change the component id value. So only component id value you change here only, because here the difference is greater than 2. That's it. So in the end just iterate over all the queries one by one. Okay, so here 0 1, so 0 and 1, see 0 1 2, okay 3. So both are having different values, both are in different component, you can say. Okay, so here both are in same component, return true. Okay, here right 1 3 both are in same component, 2 3 and both are in same component, 0 2 is in different component. Okay, so only with 0 we have getting the different component. So very simple, right? So this is what we need to do. Okay, so this code is also very simple. Okay, so nothing complex here. Instead of here I'm using the here now, let's do one thing here. Let's delete this. Okay, we don't need this, right? We don't need this, we don't need this also. Okay, we don't need this also, right? And here what we need one component. Okay, int component new uh, int and value, right? And here you have to take int component id and set it to 0 initially, and here you have to just run this. Okay, and here if nums of I minus nums of I is greater than max difference, then only in that case you have to increment the component id, right? In that case only you have to increment the component id, right? Component id plus plus. All right, and otherwise, okay, always, but you have to do after that you have to just update this component of I. So here you have to just write component of I value equal to the component id that you have incremented here. That's it. And here same thing, and here instead of this now you are creating this component array, not you are going to find parent, so just change it. Component of this and component of this, if both are matching, return true, otherwise false. Okay, we are not calling any method, we are just using this array, right? So use this. So, okay, this should be deleted, right? This is done, this should be deleted. No, it should be here only, and this and here. Okay, so now let's run the code and see if there are code issues. We'll try to fix that. So the test case has been accepted. Wonderful. Now let's submit it. Okay, so see, our solution is accepted, and the time complexity for this problem is going to be of n only, right? Very simple, only one loop we are using here, right? And we are here, we are iterating of the over the queries only, right? So that's it, right? So I hope that you guys are able to understand today's problem, and if you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you guys in the next video. Thank you. Bye bye.